Hi, in today's video, we'll have a look at the type 1 and the type 2 errors in statistical hypothesis testing. So let's have a quick recap of how to conduct hypothesis testing. So we always follow the same procedure. We state the null hypothesis, H0, and the alternative hypothesis, H1, and then we calculate the test statistic, assuming that the null hypothesis is true. And then using the known distribution of the test statistic under the null hypothesis, we calculate the p-value and then set the significance level for the test, usually at 1% or 5%. And then if the p-value is below alpha, we reject the null hypothesis, and otherwise we do not reject the null hypothesis. So there are two types of errors that you can make when testing a hypothesis. The first one is the type 1 error, where we reject the null hypothesis even though the null hypothesis is correct. And then there's the type 2 error, where we fail to reject the null hypothesis even though the null hypothesis is wrong. So let's start by thinking a little bit more about the type 1 error. So what determines the probability of making a type 1 error? Well, if we look back at a previous example where we're looking at the mean age in the population, and our null hypothesis was that the mean age was equal to 21, and the alternative hypothesis was just that the mean age was different from 21. And in our particular sample, we had found that X bar was equal to 22.3. Okay? And we had calculated the p-value for that test, and we had seen that basically this area in blue corresponded to 3.8%. So that it was a 3.8% of getting a sample mean that was at least as extreme as what we had observed, that is at least 1.3 units away from our null hypothesis. Now, remember that we said that we would reject the null if the p-value is less than our significance level alpha. Okay, and our significance level alpha, let's say, is 5% in this case. So even if the null hypothesis is true, 5% of the time, we would reject it. Okay? So the probability of making a type 1 error, in this case, would be 5%, because as long as the p-value is less than 5%, we would reject the null hypothesis, even though the null hypothesis is correct. So what determines the probability of making a type 1 error is just the significance level. It's actually equal to the significance level. So now let's think about the type 2 error. So the higher the statistical power of a test, the lower the probability of making a type 2 error. And actually, if we call the probability of making a type 2 error beta, then the statistical power of a test would just be 1 minus beta. So what determines the statistical power of a test? Well, let's think a little bit about that. So the statistical power of a test is affected by different things. So first of all, it's affected by the sample size. So if the sample gets larger, then we get smaller standard errors, and it therefore becomes easier to detect differences. So we have higher power, we have a lower probability of not rejecting the null hypothesis, even though it's false. So second factor is the effect size. So if we have a null hypothesis that is false, let's say that we make a hypothesis that the mean age in our sample is, let's say, 21, but that the truth is that the mean age is 82. Well, clearly, this will be an easier null hypothesis to reject than if the true mean is 21.3. This still means that the null hypothesis that we're testing is false, but as you can imagine, this is harder to detect than a mean that is vastly different from the hypothesized null. The third factor that matters is the significance level, alpha. So the higher the alpha, the larger the rejection region, and so the higher the power. But here you need to realize that obviously that comes with a trade-off, because if you have an alpha that is relatively large, let's say 10%, that also increases your probability of making a type 1 error. Okay, because we had said that the probability of making a type 1 error is actually equal to alpha. So here you need to find some kind of balance between reducing the probability of making a type 1 error and the probability of making a type 2 error. Okay, but in practice, most of the time people pick 5% or 1% for the significance level. But remember that when you lower the significance level, that will have a negative impact on the power of your statistical test. And then the variability in your sample, so sigma squared, if you have a lower variance, then you get more precise estimates, and that leads to higher power. So that was an overview of the two types of errors that you can make when conducting a statistical test. The type 1 error, where you reject the null hypothesis, even though the null hypothesis is correct, and the type 2 error, where you fail to reject the null hypothesis, even though the null hypothesis is false. So that's it for today's video, and I'll see you in the next one.